We are asked to find the equation of the plane that passes through these 3 points, P0, 1, 1, 1, P1, minus 2, 0, 4, and P2 is the point 6, 1, 2. Before we think about it, let's make sure this is a reasonable question. Let's make sure we believe that given 3 points, we should be able to find a plane. If I give you 2 points in space, we should be able to find a line that goes between them. Now, if I give you a 3rd point on that line, well, that's not going to tell me anything interesting. It's literally on that line. But if I give you 2 points, and a 3rd point not on that line, that seems like it should tell me a plane. The way I like to think about that is if I have 2 points in space, P0 and P1, they would generate a line. If I give you a 3rd point, P2, that doesn't lie on that line, I then can draw more lines through the other pairs of points, giving me a triangle. And then that triangle would live in a plane, right? So I get a plane determined by 3 non-collinear points, 3 points that don't all lie on the same plane. So I'm given 3 points here. This seems like a reasonable question. I think I should be able to find the equation of a plane that passes through these 3 points as long as they don't all actually live on the same line. Okay, so what do I need to find the equation of a plane? Well, I need a point. I actually have 3 of them. I'm going to choose to use this one that I've already labeled P0, which will come in handy, though I could have called them A, B, and C and just chosen a point at random. And I need a vector n that is A, B, C, that is perpendicular to the plane that I'm dealing with. So how do I find this vector perpendicular to my plane? Pause the video here and see if you can think of a way to generate a vector that's perpendicular to the plane that's containing P0, P1, and P2. What I'm thinking is that since I'm looking for a vector perpendicular to something, I'm thinking about a cross product. I might want to take a cross product. And in fact, I see vectors that I could think about. And actually, I could draw any kind of vectors between these 3 points, but this vector and this vector will work, and if I take their cross product, I'll get a vector perpendicular to both of those vectors, perpendicular to the triangle I drew, and more than that, perpendicular to the plane that I'm considering. So I'm going to let the vector u be the vector that's pointing from P0 to P1. All right, so P0 to P1. All right, so minus 2 minus 1 is a minus 3. 0 minus 1 is minus 1. And then 4 minus 1 is 3. V. I'm going to let that be, that's all right, so I just found u. Let's find V. We'll let that be the vector that points from P0 to P2. All right, so I'm looking for the vector that points from P0 to P2. 6 minus 1 is 5. 1 minus 1 is 0. And 2 minus 1 is 1. So my vector n should be u cross v. So I need to evaluate this cross product. All right, so I'm gonna evaluate this cross product. You could pause the video here if you wanted to and do it on your own. All right, so I need to take the determinant of this little 2 by 2. That would be minus 1 times I. All right, now I need to take the determinant of this little minor matrix. So minus 3 minus 15 is minus 18, but the one in the middle, the sign gets flipped around, so that's plus 18j. And then finally, I need to take the determinant of this little 2 by 2, which would just be 5. So there's my vector n. A is minus 1, B is 18, and then C is 5. I was given a point P naught at the very beginning, which was the point 1, 1, 1. And I'm ready to write down the equation of my plane. Minus x plus 18y plus 5z is equal to the dot product between this vector and the vector that points at 1, 1, 1. So I just need to add together minus 1, positive 18, and positive 5. And let's see, minus 1 plus 18 is 17, plus 5 more is 22. And so there's the equation of my plane, which would be just as well to write down like this. Multiplying everything by minus 1 so it starts with a positive term. What's nice about that is we actually see two things. This vector is perpendicular to minus 1, 18, 5, but it's also perpendicular to positive 1, minus 18, minus 5. Should be a z right there. Well, if I change all the signs on that vector, right, I have the vector pointing in the opposite direction. The plane's trapped between this vector n and its opposite. In fact, if I switch the order on my cross product, I get this equation rather than this one, and that would be perfectly fine.